In this video, we will explain the classification of forces, type of forces.
Let us check this animation. We have a magnet here and we have a key. Let us pull for the first time. Nice. So let us pull it slowly here. Let us use a small magnet. Here we can observe that we have two types of forces. When we are using the magnet is catching the key before touching it. While I'm pulling the trigger, we should touch here. And this force is a contact force. So we can notice that force acting from a distance and we have contact force. The first force that acts from a distance is the magnetic force. The magnetic force can be attraction or can be repulsion. Here if I use two magnets, they will attract each other. Without touching each other, they attract. Well, if I rotate the magnet, look what will happen. They repel each other from a distance. And this we call it magnetic force, acts from a distance. Second force. Here I have a balloon and a cloth, and nothing will happen. If I put the balloon here, it will stay still. If I bring another balloon, also they are at rest. Let us put a charge to this one. This is negative charge and the cloth now positive charge. What will happen if I leave the balloon? They attract each other. If I add also negative charge to this balloon,
Now look, the balloons are repelling each other.
here I will put the balloon here.
We observe that the two balloons repel each other,
Since minus minus repel each other,
while minus plus attract each other.
look here, the minus will attract the plus while the minus will repel the minus. Unlike charges attract and like charges repel each other. So this is, we call it electric force. Here, unlike charges attract each other, like charges repel each other. We call it electrical force. I still have one force that acts from a distance. If I have a skydiver, when he jumps from the airplane, he falls downward. Why? Yes, because the Earth's gravity is attracting skydiver toward it. Here we can observe two forces, the weight force pointing downward, while we have something that we call air resistance. When the air touches the body of skydiver, apply contact force on his body vertically upward, while the weight is vertically downward and it is acting from a distance because the skydiver is not touching the ground. So here an apple
Falls down.
why? Because gravity is attracting it toward the earth. Also, when we jump, we go back to the ground since the gravity is attracting us downward. Whenever I open a tap of water, the water will fall down because of gravity also. If I leave this boy, also he will come down to the ground because of gravity. And gravity is a force acting from a distance. These are the three forces that are acting from a distance: magnetic force, electric force, and gravitational force. Let us check the contact forces. This boy apply a force on the stone and the stone moves. Also he kicked the stone and also the stone moves. Here the boy is pushing the table and here he is pulling it. These are contact forces. So these forces, we call them muscular forces. Second force. We all love this game. Let us check what will happen. If I put this man here and this man here, and we'll start the game. Go. The big man is stronger. I will let this man help him. Okay. I will let them help here. We have force, muscular force. And because we have a string or a rope, we can say that the rope is applying a tension force on the trolley. I can draw a tension force in this direction, and here I can draw another tension force in this direction. Of course, you notice that I draw this force longer than this one because the red team win. So here also we have a force upward since the rope is pulling the wheel upward. Call it tension. Whenever a string or spring or rope is applying a force on an object, we call this force a tension. Third contact one. If we apply a muscular force on the box, it moves, then it stops again. Why the box stops? Let us check it another time. If I push the box here, why here the box is not stopping? While now, whenever I push it now, the box stops. Because if you can see, there is a friction between the box and the ground. Here, the ground is wood. While when I change it here, it's an icy ground, no friction on it, and the box will not stop. While when we put wood on the ground, there is a friction force, and this friction force will stop the box. Whenever we rub our hand against each other, we feel hotness. This because of a friction. And this is our third contact force. What about this force? If this boy jumps here, he will fall down. Nothing will stop him. But if we put a track here, he will not fall down to the ground because this track applies a normal reaction. So this is the normal reaction that the track applied on the boy. Also here, if I apply a force on this box and I leave it, it will continue moving.
But if I put a barrier,
It will reach to the barrier and stops. Why? Since the barrier applies a normal reaction in this direction. This is we call it normal reaction. Also here, if we remove the boy will fall down. So the ball is applying a normal reaction on the boy to prevent him from falling down. So this we call it normal reaction. So these are the contact forces. Muscular forces, push and pull, tension forces, friction force, and normal reaction force. While forces acting from a distance are magnetic force, electric force, and gravitational force. Let us discuss about weight. Any object beside the Earth falls toward the Earth because of the gravitational force that we call it weight. So this rock has weight, but the rock is not falling down because we have a normal reaction equal to the weight vertically upward. This normal reaction is acted because of the ground. The ground apply a force on the rock vertically upward. We call it normal reaction. If I apply a horizontal force, what will happen? The rock directly falls down. While the stone is falling down, the only force acting on it is the weight. So it falls down toward the earth. When it reaches the bottom, again we will get a normal reaction to keep the stone in equilibrium. So when an object near the earth's surface is released, it falls vertically downward. The object falls freely under the effect of the force of attraction exerted by the earth on it. The Earth's attraction on an object is called its weight and is symbolized by W vector or mg vector, and the vector is only on the gravity, on the g. So this is the Earth, and this is the weight of the moon, since the Earth is attracting the moon towards it. And this is the satellite. The Earth is attracting the satellite vertically downward toward its center because of its gravity. So the formula used to calculate the magnitude of the weight is W equal m times g. M is the mass of the object. The SI unit of the mass is kilogram. W is the weight and SI unit is Newton. G is the gravity, the gravitational field strength, and the unit is in Newton per kilogram. W equal mass times gravity. If we need the mass, then mass equal weight over gravity. If we need gravity, gravity equal W over the mass. We can calculate it directly from the rule. Weight equal mass times gravity. Then mass equal weight, and I will take the gravity before the equal. The times will change into divide, and I will get weight over gravity. And if I need to calculate the gravity, gravity equal weight, and I will take the mass. After the equal, the times will become divide, and gravity equal weight over mass. Characteristics of the forces. As we already explained, the force has four characteristics: point of application, line of action, direction, and magnitude. Let us start with weight. If we have this apple, and you know that the weight is a force acting from a distance, what is the point of application of this force? All forces that acts from a distance, the point of application is the center of gravity of the object. So here the point of application is the center of gravity of this object. This is the blue dot, is the center of gravity of this apple. What is the line of action of the weight? The line of action of the weight is vertical. Direction. The direction of the weight is downward. Always the earth is attracting all the objects towards it. So the direction is downward. And the magnitude is m times g. This is the direction downward, the symbol w vector or mg vector, and the magnitude without vector, the vector for the direction, and the magnitude we remove the vector, m times g. Tension. If we have this spring and we suspended box from the end of this spring, we notice that the spring is pulling the box upward, preventing the box from falling down. We all know that the earth is attracting the box downward and the box must fall down. But it's not, because the tension is preventing it from falling. So what is the point of application of the tension? Here we can notice that the contact point between the box and the spring is the point of application of the force. So the point of application is the contact point between the rope and the box. The tension is a contact force. The line of action is always along the spring, and here we can draw it vertically since the spring is vertical. What is the direction? Here the direction is upward. Since the box is going downward, the spring is pulling it upward. And the magnitude is capital T. As we said before, the tension with vector. Here on the drawing we should write it tension vector, but the magnitude is T alone. Here, and this is the force of weight. Of course, the point of application is the center of gravity of the box, and the line of action vertical, the direction is downward. These two forces now are equal since the box is at rest. If we use this figure, a ball is connected to a string. If we are using string or we are using spring, it's the same. We will call this force tension. The point of application of the tension is the point of contact between the string and the ball. Line of action along the string, and the direction is upward. And this is the weight also. The center of gravity is the point of application, line of action vertical, and the direction is downward. Now let us speak about magnetic force. Magnetic force, if I have a magnet, of course we all know that the magnet will attract the iron nail by a force that we call it magnetic force. And this force, as we already explained, it's a force acting from a distance. What is the point of application of this force? Because it is a force acting from a distance, then it is the center of gravity. What is the line of action of this force? Is the line joining the object and the magnet. The line joining the center of gravity of the object and the magnet. What is the direction now? towards the magnet, and the magnitude is Fm. So this is the direction towards the magnet, and this is the force F vector M. So whenever we approach a magnet toward an iron nail,
directly the magnet will attract the iron nail.
by a force we call it magnetic force, and it is a force acting from a distance. Now we will speak about normal reaction. If we have a box resting on a table, of course the table will apply a force on this box to prevent it from falling to the ground. And this force we call it normal reaction. What is the point of application of this force? It's the contact point between the ground and the box. What is the line of action of the normal reaction? Here it's vertical, but normally we write perpendicular to the surface. So always the normal reaction and the support or the surface, they make angle 90 with each other. What is the direction? The ground is preventing the box from falling down, then the direction of the force is upward. And the magnitude, we call it N. N vector on the diagram, on the figure, and the N for the magnitude without vector. And this is the weight. What will happen if we put this box on an inclined plane? As we can see, that the weight didn't change. It is vertically downward. While the normal reaction changed. Why? Because it should always be perpendicular to the surface. Now we'll speak about the last force, which is friction. If we have the box, as we said before, we have normal reaction perpendicular to the surface upward, and we have weight vertically downward. If this box is at rest, then no friction because we have a horizontal surface. But if this box starts to move with a velocity v, thus we can notice that we have friction opposite to motion. So the point of application of the friction is the point between the ground and the box, same as the normal reaction. Line of action along the surface, and the direction opposite to the motion, with the magnitude small f without vector. When the box starts to move, we have a friction opposite to the motion. To sum up, all these forces, weight, mg, tension, friction, normal reaction, and magnetic force, point of application for the weight center of gravity, and for magnetic force also center of gravity. Here center of gravity and center of gravity for weight, and for magnetic force and electric force, since they are acting from a distance. All forces acting from a distance, the center of gravity is the point of application. While tension, friction, and normal reaction, the point of contact between the rope and the box, the point of contact between the ground and the box, the point of contact between the ground and the box, since these three forces are contact forces, then they need a contact point, which is the point of application. The weight is vertical, downward always, and the formula to calculate the magnitude is W equal mass times gravity. The tension always along the string or the rope or the spring. The friction along the surface, and the normal perpendicular to the surface. Magnetic force and electric force, line joining the object and the magnet, or the line joining the two charges. If I have positive electric charges, they will repel each other, and if I have positive negative, they will attract each other. The magnet,
Always attracts magnetic materials or metals.
like iron, the magnet will attract the iron. The magnitude for all these without vector, we are not allowed to write a vector while we are writing the magnitude or calculating the magnitude. The friction is always opposite to motion, and the normal reaction is away from the support. If we are speaking about ground table, it is upward. And the tension is towards the source of the push. Let us make some examples. Forces acting on the box are, we have this box and the boy is pushing the box to the right with a velocity v by a muscular force. First, if I have this box, first I have the weight vertically downward and the point of application center of gravity, normal reaction perpendicular to the surface upward, and because we have velocity, I will get a friction opposite to this velocity. This is my friction. When the box stops, directly we don't have friction. The friction will disappear. If I push the box to the left, the velocity will be to the left and the friction will be to the right. So first I have the weight mg vertically downward. So I will draw it from the center of gravity vertically downward mg vector. To revise the characteristics, weight, the point of application is the center of gravity, line of action vertical, direction downwards, and the magnitude is mg. W equal m times g, mass times gravity. Second force, normal reaction vertically upward. Here, vertically upward, it's correct. Okay, it's perpendicular to the surface and the surface is horizontal, then normal reaction is vertically upward, or you can write perpendicular to the surface upward. Characteristics of normal reaction: the point of application is the point of contact between ground and box, line of action perpendicular to the surface, direction upward, and magnitude n. Third force, friction horizontal to the left. Horizontal to the left. Why horizontal to the left? Because opposite to motion. So what are the characteristics of the friction? Point of application, same as normal reaction, point of contact between the ground and the box. Line of action along the surface, yani horizontal here, along the surface, horizontal. Direction opposite to motion, here to the left, opposite to motion, and the magnitude is F. Last force is the force of the boy. Because of the force of the boy, the box moves to the right. So pushing force F, or muscular force, it's a pushing force horizontal to the right. Characteristic of muscular force, it's a contact force also, so it's the contact point between the hand and the box. The point of application of the muscular force or the pushing force is the point of contact between the hand and the box. Line of action horizontal and direction away from the man to the right. Towards the man if it is a pulling force, if I'm pulling something towards me, if I'm pushing away from me, and the magnitude is F. Another application, we have a box and we are pulling it by a string. So the box is going upward. Here, if the box going upward, first I have weight vertically downward. We have normal reaction, of course, but now it is perpendicular to the inclined plane, making an angle 90 with the inclined plane. And because we have velocity, the box is going up the inclined, then I will have friction because the inclined plane is rough, not smooth. If the inclined plane is smooth, then no friction. If the inclined plane is rough, then we have friction opposite to motion, parallel to the inclined. When we stop, the friction again disappear. Of course, the box will not stay there. It will go back down because here we are not pulling it by a string. The box will slide down the inclined. The velocity will be downward. Of course, the friction opposite to the velocity, and the box falls down. First, the weight mg vertically downward. This is the weight mg vertically downward. And here the characteristics: normal reaction and perpendicular to the surface upward. Here we cannot say it is vertical upward because it's no longer vertical. It is perpendicular to the surface or perpendicular to the inclined. The characteristics: normal reaction, point of application, the contact point between the ground and the box, perpendicular to the surface is the line of action, direction upward, and the magnitude is n. Third is friction along the inclined opposite to motion. And here we are pulling the box up the incline, then the box is moving up the incline. So the friction will be opposite to the motion. It will be down the incline. Characteristic of friction, point of application is the point of contact between the ground and the box, same as normal reaction. Line of action along the surface, direction opposite to motion, and the magnitude is F, and friction is a contact force. Tension along the string. Point of application is the point of contact between the tension and the box. Here, this is the point of application of the tension. Line of action along the string, direction. Here I'm pulling it up, so the tension is up the inclined. The last application, we have here an iron box and we have a magnet. Weight vertically downward from the center of gravity, and these are the characteristics. Second, we have normal reaction vertically upward. Here, since it's horizontally, we can write it's vertically upward or perpendicular to the ground. So this is the normal reaction, and the point of application of the normal reaction here, it is with the contact point between the box and the ground. Line of action perpendicular to the surface or vertically upward, both are correct in this case. Direction is upward and the magnitude is N. So magnetic force is a force acting from a distance. So it is horizontal to the left towards the magnet. And the point of application of the magnetic force, since it's a force acting from a distance, so the center of gravity is the point of application of the magnetic force. Line of action, the line joining the object and the magnet. Here it's horizontal, and direction toward the magnet, here it is to the left, and the magnitude is Fm.